Hello, and welcome to our Blue Cross Blue Shield Ansible automation project. My name is Monty Vanderlinde. A quick little note about me is my favorite programming language is Java, and my least favorite is C#.
I'm Jarrett Meester, and my favorite programming language is Python, and my least favorite is JavaScript.
Hi, I'm Robert Henderson. I'm a graduating senior, and I quite like C# as well as Python. I don't like PHP, though.
And I'm Eric. I'm also a graduating senior, and my favorite programming language is also Python, and my least favorite programming language is somewhere between vanilla JavaScript and PHP. So to start us off, let me give you guys a bit of a background. So when making sure a system is secure, the first thing that you want to do is update the system and apply the patches to any and all programs, as well as the operating system itself. Windows, of course, likes to apply these patches automatically, usually right in the middle of an important assignment they haven't saved in the past 3 hours. Due to this annoying coincidence, most people like turning off the automatic updates and won't do the updates until they're forced to. Now, imagine needing to manually apply these patches to multiple computers, sometimes hundreds of them. There's got to be a better way, right? It's annoying to go to each computer, click through the settings, or type into the command line, or whatever it takes. And usually there is a solution to automating this process, but most of the time, this automated solution costs tons of money, and it's no guarantee that it will work with your setup. So applying these patches still feels like a chore, and it's one reason that it's often the first thing forgotten or ignored. Our project aims to improve this process by automating for our specific environment some of these more tedious tasks. Next, Robert will talk about our sponsor, Blue Cross Blue Shield.
At Blue Cross Blue Shield, our sponsors' names are Eric Holmberg and Craig Doctor. Craig Doctor has helped us by mentoring us through this project and giving us all the support that we could ever want. And Eric has helped by keeping us on track and scheduling our online meetings. So how does BCBS play into this picture of tedious patches? Well, due to the internal and external regulations that they are required to abide by to patch their servers, they have to do it on a weekly cycle. Their servers number in the hundreds. I mean, can you imagine walking around to each of those servers, logging in, typing on the keyboard through the command line just to update them? It's ridiculous. Currently, they use a software called BladeLogic to do some of the automation for patching their servers. BladeLogic has cost them quite a chunk of change over the years, and they're looking to replace it with something homegrown. The last part of our puzzle is the server operating system that they are using. It is a Linux distribution called RedHat Enterprise Linux. We will talk more about it later. I'm going to hand it off to Monty to tell you about our tools for success.
Thank you, Robert. So what kind of tools are we using over the course of this project? So firstly, Ansible is an automation platform that can be used to connect with a variety of operating systems, including RedHat Enterprise Linux 7, which is what is used on most of their servers at Blue Cross Blue Shield. So RHEL 7, or Red Hat Enterprise Linux for short, is an RPM-based distribution, which uses the Yum package manager to gather information about packages, and then to install new packages if they want, or to update all existing packages. Now, Jinja2 integrates nicely into Ansible to provide formatting and templating support. To keep track of our work, we are going to use GitHub as well, an industry standard tool that makes it very easy to keep track of what everyone's doing and to roll things back. Red Hat Enterprise Linux 7 is a paid enterprise OS, which we did not want to use for our development efforts. So we decided against that, and we chose to implement our environment in CentOS, which is very similar to Red Hat Enterprise Linux and has many similar libraries. Now, we're going to pass it off to Jared, and he's going to tell us a little bit about the package manager for both Red Hat Enterprise Linux and CentOS.
Yes, with as many open source projects as there is, it can be kind of tough to keep track of all of them. A popular way to keep track of them is through repositories, either on the internet or ones you have yourself locally. You could use RPM functions to obtain and install your packages, but more commonly, we use a front end for that kind of thing. Front ends help take care of dependencies as well as obtaining and maintaining. Yum is one of these front ends and is still very popular since its adoption in CentOS 5 and RHEL 5. Blue Cross Blue Shield has an increased security need for patches and upgrades due to the sensitive nature of their work, and because of that, it means it's very important for their front end to support local repositories. After security personnel and database admins approve packages, they clone the packages into the local repository for distribution. By keeping the repository local, they can ensure maximum security and track any security threats should one get through. Next, Monty will talk to you about Ansible.
Thank you, Jared. So what exactly is Ansible, and why did we decide to use it? So there are many things that make Ansible an incredibly useful tool to learn, just in general. Not only is it very easy to learn and very well documented, but its use of SSH makes it incredibly secure and compatible with most current infrastructure, as SSH is the tool that is commonly used to connect to remote machines. And perhaps most important of all, automation is supposed to simplify tasks and not make them harder or more complicated. Ansible is a tool that understands this very well, which makes it an excellent choice for projects like ours. Ansible is a scripting language that takes advantage of YAML and Python to perform tasks on remote machines. The backend of Ansible is written and executed in Python, which makes it highly transportable and adaptable, since Python runs on almost everything these days. YAML is a human-friendly data serialization standard for all programming languages. These two things together make it perfect for quick and silent automation. To connect to other machines, Ansible takes advantage of SSH, the secure shell protocol, to transfer the YAML configuration file and then runs the file using Python in the background. After the file finishes running, it returns some statistics and other specified data back to the Ansible host server. You can transform that output using a templating language like Jinja2, which we used in our case, and you can use it to make the output more readable. Ansible is a useful tool in any server admin's tool belt, if only because it's easy to use. The other things Ansible has going for it is that it is well supported and well documented. Now we're going to hand it off to Eric, who is going to talk about templating with Jinja2.
Thank you, Monty. When we run our script to find what updates are needed for each server, the output is returned in a format called JSON, which on its own is rather hard to read. To help the team more easily understand the output, we needed to change how it was written programmatically. To remedy this, Ansible comes with a tool called Jinja2, which uses the Python engine to format the output of our scripts. Jinja2 allowed us to make rules for how our final document should look and link it directly to the output of the Ansible script. For example, when we send out a query to other servers, it returns a dictionary of result parameters and a list of direct results. We can use standard Python functions to edit these lists before we print them out. This allows the server administrators to see directly and in clear English what servers need what updates. Jarrett will now talk about how we kept this train wreck on the rails.
In any project, a hot topic is source control. What is it, and why should we use it? Source control provides many useful features. Some of the more notable ones are version history, collaboration tools like merge resolution, and an easily accessible place for saving. Version history is useful in the scenario where you royally screw something up and nothing seems to work when trying to fix it. Source control allows you to roll back those changes to a working version and then try again. When you have multiple people working on the same document but in different areas, how do you combine the changes? Source control, like GitHub, can automatically make those changes and save them together for you. In the case where you both change something, then GitHub will show you the conflict and allow you to resolve it. Having multiple people work on a project is always a challenge, even more so when each person carries their own flash drive of their latest version. Source control provides a central location for the latest version when used correctly. The reason we chose GitHub specifically to be our source control is that it has a wide adoption, and the skills learned by using it can be transferred to almost any other project. We're happy to introduce GitHub to Blue Cross Blue Shield. GitHub is also free and allows you to have private repos for sensitive projects, such as one like this. Now Robert will talk to you about why we are using CentOS servers.
Thank you, Jarrett. When we're talking about servers, we said before that Blue Cross Blue Shield uses RHEL servers. And yes, that's different than CentOS servers. So why are we using a different Linux distribution, you might ask? Well, CentOS, the community enterprise operating system, is a downstream version of Red Hat Linux that is lightly modified, repackaged, and distributed for free. This makes it a very compatible with normal RHEL systems and a great environment for developing if you're a poor college student. Plus, it removes all of the licensing headaches. However, and most importantly for our project, all the dependencies we used are either standard on Linux systems or easily installed on Red Hat Enterprise Linux. So even though we could not access real Red Hat Enterprise Linux servers, we were able to mimic them closely enough so that what we wrote would work on both. Because CentOS is also an RPM-based distribution and uses most of the same packages that Red Hat Enterprise Linux uses, it makes it a great choice for our project. Now that we have all of our pieces, Eric will talk about how these fit into our goal.
Thank you, Robert. This project, as a whole, to Blue Cross Blue Shield, is a way to save money. As a larger picture, they are looking to possibly replace BladeLogic with a more specific homegrown piece of software. And this specific capstone project was meant to be that first step towards their full server automation system. The expectations for us was to create a system that generated the report that listed all of the necessary security updates for each and every server. Then the next step that Blue Cross Blue Shield would take would be to take the report that was sent out to server administrators and preview the necessary updates so that they could prepare the server for these updates, such as scheduling it and selecting the updates onto their repository. We decided to use Ansible playbooks to run yum commands, which compare the update versions on each and every server to those on the repo. Then we used Jinja2 to format the output of that comparison so that the humans could read the report that was sent out. This being the first step in the larger process is something that they will be using quite soon on live servers to help take out a part of the BladeLogic infrastructure and hopefully grow it further and further into a complete replacement. Next, Monty will give us a live demo of the program.
Thank you, Eric. So, looking at the video on screen, at the top, we just tell it to run our script, and then it gathers some facts about what's going on, and it lists all of the different repositories that are on the system and which ones are enabled or disabled. As you might be able to see, there's 3 that are currently enabled, and these are the remote repositories, where it's going out to and pulling updates down from the official Red Hat servers. From there, it's going to update the local repository and take all of the packages that are out of date and remove them and update ones that need to be updated. Now, this process might take a little while since there's quite a few packages to update, so we'll talk about how this is going to be theoretically used on their system. What they're thinking about using is Ansible Tower, which is a special piece of software that allows you to run Ansible scripts in specific ways. And one of the main ways that they might use this is just telling it to run once every night at 3 in the morning. So they don't really have to worry about manually dealing with running the script on a regular basis. But now we're getting some more update here. Some more updates are showing on screen. These are the types of this is the type of output that would normally be shown on screen if you were updating the server in person. But Ansible takes that output, packages it up, and ships it over to the host machine, where you can see all of the nice output without needing to walk over to each individual machine manually. Now that it has updated all of the base packages, it has to update the XML metadata, because this is what Yum actually uses to know what packages are available on the local repository. It's going through and checking which packages have changed, which have not, what's available, and listing out everything that's now available. And finally, it has moved over to the other servers, and as we can see, there's a bit of a list at the top of all of the updates that are needed. And at the bottom, it also sent out an email, but now we're going to scroll up and look at all of the updates that our servers need. At the top, you might be able to see it says development BCBS, that is the host name of the server, and in the middle, maybe you saw minimal BCBS, which is the host name of the other server. This is the formatted output, or one of the formatted outputs, as there are 3 different files that they could potentially choose from to send out in an email to the system administrators. But we will leave that up to them to choose which one they prefer. Anyways, we're going to now wrap up and pass it off to Robert for some final thoughts.
Thank you, Monty. I wanted to wrap it up by talking a little bit more about each of our roles on this project. To start off, Monty has been our main development support, and he did a lot of the writing of the Ansible scripts and general setup of the servers that we maintained. Jared and Eric helped a lot in the Jinja2 formatting department, and I helped with getting all of our documentation set up and making sure that we can kind of keep on track. So we had a little bit of work that we wanted to get done at the beginning of the semester, but we weren't able to quite wrap that up due to extenuating circumstances. Some of these stretch goals including outputting a report in multiple formats. What this would mean is we wanted to be able to sort based on different criteria and maybe highlight some of the more important things based on feedback from the server admins. We also wanted to integrate our project with Ansible Tower, which is the the paid-for user interface of Ansible. There's also a free interface called AWX, which we would have used to mirror Blue Cross's implementation. Blue Cross is also going to use what we developed to create a full server automation system that runs on their servers. Learning to delegate tasks and focus more effort on the documentation side of the project would have made this project a much more pleasant experience overall. We were a little behind in getting our documents in. Aside from that, we faced some issues with our server setup. Most of these could be fixed with a quick kind of call to Guy Hokinson, who is the helpful IT wizard. But one of these issues was an IP violation. NDSU didn't want us serving CentOS files, and it required us to set up firewalls on our server. In the end, we created a system that could compare the updates on a server to those available on a repo server and generate a report of these updates to be applied. This is the first step in Blue Cross Blue Shield's new server update automation setup. I'd like to take a minute to thank Craig and Eric, our sponsors at Blue Cross Blue Shield, for their help, guidance, and the opportunity to work on this project. I'm going to have Jarrett give you guys some more information on how to contact us if you have any questions.
Yeah, if you have any questions about this project or this presentation, you can go ahead and contact us at our emails as listed on the screen right now. We'd be happy to answer anything that is within our capabilities to answer, anything we know enough about. Other than that, I think that's all.
Thanks for listening.